Okay, finding turning points. Now, firstly, let's just think about the same question. Okay, y equals x squared. I said that turning points, they sort of usually overlap with stationary points, but they don't always, right? So number one, I can find a stationary point, and it's not a turning point. Okay, so I can't say turning points exist when the derivative is 0, because that's not always true. We just looked at a counterexample, right? So what you'd have to say, if your question was, find the turning points, is, turning points may exist. Okay, there's a big difference. They may exist when. Okay? From there, it sort of proceeds very similar to the previous thing, right? We're going to find out where the coordinates of the point are. Eventually, you'll get 0, 0. Okay? But at this point, all you verified is that it's a stationary point. Okay? So, if, for instance, let's actually do y equals x cubed, right? Because it turns out the stationary point is at the same place. Okay? So I've solved for the derivative being equal to 0, and I've landed here. Okay? I've shown it's a stationary point. Now I need to find out, is it a turning point or not? Okay? Now, there are two methods to verify whether it is or not. I'm just going to go show you the first one. The second one comes with the second derivative, which we'll look at tomorrow. Okay? Really quickly. Draw yourself up a table. Okay? It's got two rows. The first one is x, and the second one is dy on dx. Okay. And then, what you want is a table of values for yourself. So you start at, or sorry, not start at, in the middle, you've got the value that you found a stationary point at. Okay. So at 0, what's the derivative? It's 0. Okay. Then you need to pick a point on either side. Okay. They have to be real points, like say -1 and 1. And also, these points that you choose, they can't be too far away. I'll explain why tomorrow. Okay? This will do for now. Then you need to actually find out what the values of the derivative are on either side. Okay? Now in this case, y equals x cubed, dy and dx is 3x squared. Okay? So therefore, when x is -1, you pop it in. The derivative on this side will be 3. And the derivative on this side will also be 3. Okay? It's not enough to just say positive and positive. Okay? Even though that's actually the fact that I'm after. Okay? We want to see that you've actually got some values and don't fudge it. Okay? That's one of the things Mark is really looking for. Therefore, what kind of shape do we have? Well, whatever it is, increasing, horizontal, increasing, it ain't a turning point. Okay? So therefore, I would say no turning points exist for y equals x cubed. Alternatively, if it was something that did have turning points, you know, y equals x squared, you'd say it goes negative, then 0, then positive. So you've got a different kind of shape. So you'd say there is a turning point. You might say it's a minimum turning point at 0, 0. Okay? We've run out of time.